We'll start off this lecture by stating a self-evident truth. Once again, distributed computing can get very complicated. It's hard because not only do you have to think about what is it that you want to compute, you also have to worry about resources, memory across multiple nodes. It's not just a single computer where you worry about everything on that machine. It's multiple machines, and then there are so many varieties of things that can go wrong. What happens if a node goes down? What happens if it goes down before it has processed anything? What happens if it goes down midway through processing stuff? How do we handle all of this? These, however, are repeated problems. And the beauty of the MapReduce framework provided by Hadoop is that it abstracts the programmer from all these complications. It set up a framework which has dealt with all these complications such that you can focus on what you need to achieve. You focus on your problem and you define two functions to solve your problem: map and reduce. Your map function and your reduce function focuses on your problem statement and not on how it's running in a distributed way. You have to, of course, think of it being as inherently parallel. However, everything else is taken care of by Hadoop. All you need to do is, how does your map problem work? Is it parallelized? And how does your reduce problem work? The rest is taken care of by Hadoop. This is the beauty of the Hadoop framework. There is a key insight about parallel computing that underlies the MapReduce framework. This entire paradigm is driven by one key insight which was mentioned first by Jeff Dean and Sanjay Khemawat in their seminal 2004 paper on MapReduce. And here is that simple key insight. Any problem that is inherently parallelizable, and by inherently parallelizable I mean not like a linked list where you don't know the next link before you process the previous link. There is a whole bunch of operations which are independent of each other and can be parallelized, is an inherently parallelizable problem. And any data processing task that can be parallelized can be expressed in this manner. The raw data or the problem statement can be set up as key value pairs. These key value pairs serve as an input to a parallel processing function called the map. So you start off with some key value pairs which differ based on your problem. You pass this key value to a map. The map transforms the original key value to another key value pair. So you're only dealing in terms of keys and its corresponding value. The output key value pair of the map is sent to a reduce function. The reduce function takes the output of the map, combines it and processes it in some way to give you a resultant key value. So again, remember, there are a whole number of keys and a whole number of corresponding values for those keys. It's just that your entire problem statement has been expressed in terms of these key value pairs. This is the critical insight behind MapReduce problems. Your problem statement is basically key values which are mapped, which produce other key values which are reduced, and that produces your final key value pairs, which is your result. So, how does this work? You look at your problem statement, look at the data that's available, and figure out how you can specify this in the form of key value pairs. A map task basically transforms a single key value pair to a set of key value pairs which it specifies as the output. So let's say you start with 10 key value pairs as the input to your map. Your output could be 20, 30, 100, a million key value pairs. So a single key value pair in your input has been converted to n key value pairs at the output, where n can be 0, 1, up to infinity. The reduce function takes in the key value pair that was output by the map function. So a reduce follows a map, and the output of the map is the input to reduce. A reduce task takes in all the key values it has in its input, the output of the map, and then basically combines all the values which have the same key. How it combines the values, that's what you have to specify as the developer of this MapReduce program. The basic fact is it combines all values which have the same key. So you have to be able to compare keys, say these two keys are the same. You'll get all the values associated with those keys which were different units, and then you combine them in some way. Any data processing task, any task where you perform the same operation on multiple data sets can be parallelized if it's expressed in this form. That was the key basic insight. Key value, map, key value, reduce. And you don't just need one chain of this map and reduce. You can have a chain of such transformations. So you have a map, then you reduce it. The output which is generated from this map reduce can be fed into another map reduce. So you have all these stages of transforming data till you finally get a key value pair, which is your final result. So map reduce, think of it as a chain of transformations of key value pairs. Map reduce, you can't really say it's a recent technology, but it's fairly recent. This key insight of the key value pairs and its transformation drove the creation of MapReduce by Google. And the engineers who were involved in MapReduce are basically icons today. Jeffrey Dean and Sanjay Ghemawat, and this is a small snippet of their seminal paper on MapReduce back from 2004. Here is where they described how they performed processing on large data sets, and this is the insight that they observed. They realized that their computations, most of their computations on large data sets, involved applying a map operation to each logical record, where a record is basically a key value pair. This is what they realized, and this is how MapReduce was born. So you apply a map, and then you compute a set of intermediate key value pairs. This is the output of the map, which serves as an input to the next transformation in the chain, which is the reduce operation. So then they applied a reduce operations to all values which shared the same key. And this they used to combine the data. Once they realized this, they realized they were applying it on multiple problem sets, the same basic philosophy. And that's how MapReduce was born. This is one of the secrets to Google's powerful search engine.